Welcome students. Let us start with the second chapter of grade 10, Polynomials. This is the first video for the chapter. Let us start with the definition of the word polynomials. A polynomial is an expression made with constants, variables, and exponents, which are combined using addition, subtraction, and multiplication, but not division. The exponents can only be 0, 1, 2, 3, etc. You can see this example, 4xy square plus 3x minus 5. Here we have three terms, which is 4xy square, 3x and 5. In this example, 5 is the constant. In the term 3x, 3 is the coefficient and x is the variable. Similarly, in the term 4xy square, 4 is the coefficient and xy square is the variable. Let us now see the different types of polynomials. First, we will find the type of polynomial on the basis of number of terms. First, we have monomial. Monomial is a polynomial having only one term, as we can see the examples. Next is binomial. Binomial is a polynomial having two terms, as we can see the examples. 2s plus 5, 7y minus 8, 5t minus 3. Each one of these polynomials have only two terms. Next we have is trinomial. Trinomial is a polynomial having three terms. We can take some examples as x square plus 7x minus 3. Here we have three terms, namely x square, 7x and 3. Similarly, the trinomial y cube plus 7 minus 6y has three terms as y cube, 7 and 6y. Also, we can have different types of polynomials on the basis of the degree of the polynomial. Constant polynomial is the one with degree 0. It can have any constant, any number, say 31, 3, 71, etc. Linear polynomial. It is a polynomial with degree 1. Let us see some examples as x plus 6, t minus 7, 6y plus 5 and as many as you want. Then we have quadratic polynomial with degree 2, cubic polynomial with degree 3 and biquadratic polynomial with degree 4. There's something really interesting about characteristics of biquadratic polynomial which I would like you to explore. Now, let us know something about the zeros of a polynomial. A real number alpha is the zero of a polynomial f of x if f of x equals to 0. Let us take an example. If f of x equals to x minus 4, then for x equals to 4, f of 4 will be 4 minus 4, that is 0. So, the zero of the given polynomial f of x is 4. The number of zeros of a polynomial is the degree of a polynomial. What does this mean? This means a quadratic polynomial has two zeros and a cubic polynomial, that is a polynomial with degree 3, has three zeros. Now, there must be a graphical meaning of the zeros of a polynomial. To understand this, we will first see the geometrical representation of linear and quadratic polynomials. Let us first see the zeros of a linear polynomial, that is, the polynomial with degree 1. Let us take a linear polynomial ax plus b where a is not equal to 0. This can be the graph of this linear polynomial ax plus b. As you can see, this is a straight line and the graph of y is equals to ax plus b intersects the x-axis at exactly one point, namely minus b by a, 0. Clearly, the linear polynomial ax plus b where a is not equal to 0 has exactly one 0, which is the x-coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. Now, let us see the geometric meaning of zeros of a quadratic polynomial. Let us take a generalized form of quadratic polynomial as ax square plus bx plus c, where a is not equal to 0. Then, graph of the corresponding quadratic equation y is equals to ax square plus bx plus c has a graph of either an open upward shape parabola or a downward open shape parabola. This shape depends on whether a is greater than 0 or a is less than 0. Let us now explore the three cases that arise in geometrical representation of quadratic polynomials. Case 1 will be, there the graph cuts the x-axis at two distinct points. the x-coordinates of the 2 points are the zeros of the quadratic polynomial. In both the graphs, you can see there are 2 points of intersection at the x-axis. Let us now see the case 2. Here, the graph cuts the x-axis at exactly 1 point. The x-coordinate of this point is the only zero for the polynomial. Now let us have a look at case 3. Here, the graph is not touching the x-axis at any of the points, so the polynomial has no zero in this case. Let us have a look at all the 3 cases. In the first graph, the graph doesn't touch the x-axis. It has 0 x-intercept, so the polynomial doesn't have a 0. In the second graph, we have only one x-intercept, so the polynomial has only one 0. Similarly, in the third graph, we have two x-intercepts, so the polynomial has two zeros of the polynomial. I hope the simple concept is clear to you all. Thank you.